Some of you farm in silt loam soils know about crusting, right? So when our soils are maybe not in as good a shape and maybe the organic matter isn't quite as where we'd like it to be, we're more vulnerable to crusting. When your soil's crust, what happens? Seeds can't get out, right? That's your first problem, right? Is your crop. Yeah, and almost as important, right? You got to get your crop out of the ground one way or the other. But the other piece of that is if your soils are crusted over, that water has a harder time getting down in there. And air too, which is important. So more of that water is going to run off and maybe cause, right, stuff. That's a little extreme, but that can be a result. Okay. So we want to certainly at least try to keep as much organic matter as possible because of a variety of things. Oh, there's one more really important role that organic matter plays. Yeah, so nutrients. So it supplies nutrients, and it's a really critical part of the nutrient cycling function of the soil, and it's bug food. Right? And keeping those microorganisms happy in our soil are also a critical part of soil health and quality and buffering against some of these weather fluctuations. Okay, so Quirine, I started in 1999 at ProDairy. Quirine happened to come along about a year later, and very early on, one of the things she focused research on, and I was able to help along and help some other folks who were in the position to find this research project. And we started out a long-term experiment using compost, a couple different rates of compost, what we called a high and a low rate of compost. These were dairy solids, separated dairy solids. We had 2 rates of manure, high and low. It was separated dairy manure, so it was relatively low organic matter, kind of conventional liquid dairy manure. And then we had plots that just received normal fertilizer, no manure. I'm going to talk about 15 years of this study. Each of the plots were repeated 4 times. And what we did was we had 5 years of corn silage, 5 years of alfalfa grass mix, and then I'm going to talk about 5 years of corn grain. Don't worry about all the little dots there. That's just more of a way to help me to remember the points I want to make here. So someone yesterday asked, well, geez, I'm organic and I can't grow 5 years of corn silage. I got to mix things up a little bit. And even if you're not organic, right, most of you are not having too many fields, I think, where you've got corn silage year after year after year up to 5 years like that in most situations. We did that because we wanted to have these plots did not have a manure history. So we wanted to have time to actually put enough manure, put enough this compost on, so we could start to see some real differences in the soil test. And so it took us a few years to get that going. So that's why we had 5 years. Bottom line in here is, so the compost, the high and the low are in the light and the dark blue, manure is in a green color, and when we just used fertilizer, that's in the yellow. Bottom line is, during the corn silage years, right, we're taking almost all that plant matter off and putting it in the barn to feed the cows. Not necessarily in our case, but that's how it works in the real world, right? With compost, high rates. One rate was 10 to 15 tons. The other one was 25 or 30 tons of compost. So a lot of compost. More than most people are going to really do on all their fields or even many fields. So it took with a lot of compost, we could raise organic matter levels in 5 years, even when we're growing corn silage. It's like, okay, great, Carl, I don't have that much compost, what are we going to do? So again, we wanted to see how much would we have to put on to have that impact. With that separated liquid, right, with liquid dairy manure that had the solids separated from it, we're about maybe a little bit of a downward trend in corn silage during that corn silage window. So a lot of us think about, and not everybody has separated dairy manure. We have pulled some of the solids out of there, but manure is maybe kind of helping us hold our own at least in the corn silage part of the rotation. And then when we're just using fertilizer in corn silage, our organic matter is going down. It's getting depleted faster than it might otherwise. So no surprises, but the interesting thing to us is that we could actually measure these things just in a few years of monkeying around with them. Okay, so what happened during the alfalfa years? Right, we're not tilling, we're not aerating the soil, we're slowing down that burn rate of the organic matter, no surprise. We got root systems going in there, we got crop residue dropping on top. We actually recovered things a little bit. No surprise. Not every field right in the state has hay in the rotation, but there's the benefits of hay. We didn't put any manure or solids on during these hay years. And that's important. In a couple minutes, I'll show you another slide that I think is interesting. Then, so we did 5 years of corn silage, 5 years of alfalfa grass, and now the next 5 years we did 5 more years of corn grain instead of silage. And once again, during the compost years, we started hammering the compost again, and it looks like we kind of held our own or increased a little bit. And the fertilizer plots continued to sort of go, they kind of held their own, maybe down. So we're leaving that whole stalk there, right, the corn stalk. We're returning much of that plant material to the soil, and we probably held our own during that window, okay? So you can see during the rotation, right, from 2001 through 2015, high compost we went up, low compost we went up, high manure right through that whole series of years we were flat, low manure we were flat, and we had downward to flat trends when we were just using fertilizer. Okay, so soil matter and organic matter increased with the compost. It was maintained with manure, maybe maintained to loss with the inorganic end, depending on which part of that you're looking at. Okay, so the organic matter story. What else could we see in these plots? What other things that we look for? Aggregate stability is another measure of soil health and soil quality. Anybody know what that is? So you basically go ahead, sorry, what's that?
Stickiness. Stickiness.
So the stickiness or the ability of the soil particles to hold together, absolutely. So, you know, when you plow up an alfalfa field after 5 years, you know that nice crumbly texture you got there? Those are nice stable aggregates. They're kind of glued together with some of the plant root chemicals that have been coming out of the alfalfa roots over the few years. And when you add water to that at first, those things, aggregate stability is how well does that particle, that crumb hold together? Do you want it to hold together or do you want it to break up? You want it to hold together. That's so that water and air can get down into your soil.
And it don't wash away.
Then it doesn't wash away and it doesn't crust, absolutely. Okay? So when we looked at the wet aggregate stability on these plots from those different treatments over time, we could see that high compost again, no surprise, but we could measure it. High compost, high amount of carbon, we saw a higher aggregate stability. We saw a similar, although a little bit lower with the low compost, and our high manure actually kind of stood right up there with those other ones as well, okay? And you could see the fertilizer-only plots were kind of languishing down here. So we could actually see some separation in these plots from 15 years of different management over time, okay? All right, so wet aggregate stability. This is just a high compost versus the fertilizer rate. The water's moving down in through that soil, a sample of that soil much faster. It's kind of hard to see, but there's that water on the surface is almost gone in a few seconds as compared to the fertilizer plots where those particles are kind of breaking up and they're starting to seal over, and that means more runoff coming off faster. Okay, alfalfa yield. Now I told you a few minutes ago that we were not composting, we were not manuring on the alfalfa during the alfalfa years. Okay? So the manure at least the high manure and the compost from the 5 years of corn silage previously, we are still seeing effects during the alfalfa years from that manure. Again, not a big surprise, but we didn't have to add manure during the alfalfa years, and those plots were yielding more hay than the fertilizer plots or even the low manure plot. So in this case, we use manure as that organic matter source. Yep, there's some nutrients in that manure as well that may be contributing, but that manure and compost, those solids, helped our yield during the alfalfa portion of the rotation. Okay, clear benefit. Corn grain, we kind of kicked back into corn grain after alfalfa. We started putting compost and manure on again, but still those plots separated themselves out. High manure, high compost, and actually even the low manure yielded on average higher than the fertilizer-only plots. So these are just some of the ways we're starting to quantify the value of adding organic matter and hopefully trying to build it, at least holding it in our crop fields. Okay? All right. So Sarah is now going to come up and talk about the other part of the story. Oh, you start coming on up. There was a critical piece that I just remembered I forgot to tell you. We were not doing no-till during the corn years in these plots. This was chisel disc, which represents a fair, right? I mean, a fair number of cornfields are managed in a tillage kind of rotation. So if you're doing some tillage, right, that has a big effect on how we're retaining organic matter. So we think adding organic matter, whether it's through manure or other sources, and reducing tillage, even in a dairy rotation, are going to be an important part of how we manage fields. And so Sarah's going to talk about the cover crop aspect of that sounds like many of you are pretty familiar with yourselves.
Good afternoon, everyone. Can you hear me okay in the back? Okay. So again, my name's Sarah, and I'm a graduate student working with Carl and Corrine up at Cornell. Just hold this. And my PhD project is all about keeping the ground covered all year round, specifically in forage rotations in New York. So I'm going to be going over a couple of kind of basic information, which since a lot of you are cover cropping, it might not be new information to you, but also some of the results I've found with some of my projects. So cover crops are basically just crops to keep the ground covered purely for soil health, environmental reasons. There's a number of benefits, which we've already talked about. But basically having a crop in the ground all the time, having a root system, having the soil covered, really provides a lot of benefits to the soil. One big one is erosion control. So keeping that picture of all the soil running off of a field from happening. Carl told me yesterday that a good rule of thumb is if you have a good solid cover crop on the ground, you can conserve around a ton of soil per acre that year. And if you're losing that ton of soil per acre, what did Carl say was the highest percentage of that? Organic matter, right. So not only can you build organic matter with cover crops, you can also conserve your organic matter on the field. Soil health and quality. So specifically, if you have a legume cover crop, you can add nitrogen into the soil. All the exudates coming out of the roots can provide nutrients to the soil, and to all the soil microorganisms can help with nutrient recycling. So if you have leftover nutrients from your corn silage crop, the cover crop can take up those nutrients, prevent them from leaving the field so that they can be used for subsequent crops later on. So tons and tons of benefits of cover cropping here. So what are cover crops? They're basically any crop that can be used to keep the ground covered. So some big ones are grasses, so rye, annual ryegrass, triticale, wheat, oats, legumes, brassicas, buckwheat, sunflowers. They can be grown in mixes, which are becoming really popular, or they can be grown in monoculture, like a lot of people just grow rye around here. So they can basically anything. They can be used any time of year. I'm going to be mainly focusing on the cool season cover crops, so over the winter months, but they can also be used in the summer depending on what kind of crops you're growing. So they're a really flexible tool, a really nice tool. I've talked to some farmers who specifically grow their cover crops near the road so that their neighbors can see that they're doing a good job keeping the ground covered. So whatever your goals are there, they can be a good tool. So how does it work? Well, cover crops can be planted in a variety of different ways. They can be broadcasted, they can be drilled, but you do have to manage it a little bit differently depending on how you're planting. So if you're broadcasting, you're going to need a higher seeding rate. Does anyone know why?
You have a less chance of them growing.
Right, because you don't have the guaranteed seed to soil contact. That's a big one. So if you're broadcasting, you're not guaranteeing a seed to soil contact. You might have less emergence rate, so you have to bump up your seed rate. But if you're drilling, it might take a little bit longer in the field, so you might need to figure out a different labor strategy there, but you do have a better guaranteed establishment with drilling. And terminating, so the natural termination that most cover crops can have is winter kill. So a lot of our species of cover crops don't make it through our long winters up here, so they just die over the winter time, and in the spring they're gone. So that'll be your legumes, your brassicas, some of your grass species. But some of the species come back, and that can be useful to us, which I'll talk about in a little bit. But like your triticale, your rye, your wheat, those will survive the winter and come back in the spring. So if you want to kill them and you don't want to harvest them or anything, you can use tillage, you can use herbicide, or you can just directly plant your next crop into them. Sometimes there's mixed reviews on that strategy, but it can be done. And I mentioned it before, but what's another termination strategy that could be economically useful for you? Roller quin. But what if you wanted to use it? Grazing or harvesting, right? So you actually can use it as a crop and not just as a cover. So yes, you can harvest cover crops depending on the species. We call this double cropping. So in some parts of the country, this is like a no-brainer. Of course, we have a couple crops a year, but in New York, it's a little more challenging, right? So it's a little bit more of a special scenario up here, but it can be done. We use overwintering cereals, so the most popular ones I've worked with and others have worked with are rye and triticale. And we have all the benefits of the cover crops I talked about before, and then one more big one is yield. So if you manage it correctly, you can get another crop out of the ground. And I know some people who have had a lot of good luck. Has anyone here double cropping for forage? No one?
I've done it.
You've done it? Okay. Have you had good luck with it?
It worked 1 year I did.
Work one more. Okay, good. So hopefully I can convince the rest of you to give it a try after I show you some of my data. All right, so I was part of a study that was started even before I got to Cornell, but we have 63 on-farm trials around New York, so these are on farmer farms, where we had rye, triticale, and a couple wheat trials, and we were looking at the response to nitrogen in the spring. So each of these bars represents one trial, and the y-axis, so how tall the bars are, is the yield. So you can see there's a big range in yield here. A lot of management, a lot of soil fertility explains some of that range. But see, we have some low yielding sites, but then some of our sites got up to 2.5, 3 tons of dry matter an acre. That's pretty significant. So those of you that have tried it, have you had challenges with it?
It worked fine that year.
Worked okay?
I wouldn't do it every year if it just happened to be the year that it worked.
Okay, so I want to point out that I'm not just here to tell you how amazing cover cropping is. Everyone should try it. It's the solution to solve all your problems. So there are challenges with double cropping. They can be worked around. There are management strategies you can use to make it a profitable endeavor for you, but there are challenges. The two big ones that I've run into are timing and the weather, and a lot of these can go hand in hand. So the best time to plant the winter cereals, as we heard from the last talk, is around mid-September. That's really ideal, which is a little bit earlier than a lot of corn silage comes off. So that can be a little bit of a problem there. And then if you're harvesting this for forage, you want to make sure you give enough time to get some yield in the spring, which is usually around mid to late May. And that could be later than you want to plant your corn silage. So you could run into some overlapping crop schedules here. A couple things we're looking into are using some different crops for the summer season. So using a short season corn, like a 90-day corn, or forage sorghum, or some other crops. The farmers I've talked to that have had the most success have shifted their mindset a little bit to say, okay, I want 2 crops this year. I have to change around my management system a little bit. So if you want to continue growing your conventional season corn without changing anything else, you might not have as good of luck with it. So you have to be willing to shift your management strategies a little bit to fit it in. So if you do want to harvest your rye or triticale, you do have to treat it as a crop. And the 2 main things you have to keep in mind are fertility and planting. If you ignore both of these things, you might not have good luck with it. So in terms of fertility, more than half of those 63 trials needed nitrogen at green up in the spring to get those 2.5, 3 ton yields. Okay? So most of the trials needed some sort of nitrogen addition in the spring to yield well. And planting method and timing. So again, you'll have better luck with a good stand if you drill. It'll be more of a guarantee that you'll have some establishment. And planting timing is important. So again, planting early, maybe even a little bit into late September is your best bet. If you plant into early October, mid-October, you're getting a little more risky there. It's still possible, but really, if you're wanting to get a good yield, planting sooner is the way to go. So this is more related to soil fertility and keeping nutrients in the ground. So one of our trials, we looked at when you plant the triticale in the fall and how that relates to taking up nitrogen in the fall. So this is trying to simulate having extra nitrogen left over from the corn and what happens to it in the fall. So if you plant it by or before September 20th, it can take up around 70 pounds of nitrogen per acre. That's pretty good. If you wait just a week or 2, planting after September 20th,